Greetings everyone. Naveen Kumar and Aravinda Gautam here to explain you about integer linear programming, a Matlab flow. Now we are going to see about process and solution methods for integer linear programming and linear programming and corresponding graphical approach in Matlab, and the code for generic linear programming, and the example will be a famous RK model. And we will also see binary integer linear programming and its generic code in Matlab. At last we will take a traveling salesman problem and code it and then execute it and obtain the solution. So generally, to convert a problem into a mathematical form, we need to have some specific forms. That is, we need to have an ideal goal and components, and then we need to form the variables, and then at last we need to verify the corresponding model with the applied input and the obtained output. The solution method can be as shown here. We have to choose a solver and combine the variables into one vector and write bound constraints, and then at last, after getting the objective, we will be examining the solution once the solution is obtained. Okay, why do we go for Matlab? Matlab stands for Matrix Laboratory, and you may know Matlab is an interactive system whose basic data element is an array. So whenever integer linear programming is considered, the corresponding decision variables can be coded and or formed as a matrix. So Matlab will be easiest tool to code integer linear programming. So let us consider an optimization problem. Now here I have shown a farmer has 75 acres to plant and must decide how much farmland to devote to crop X or crop Y. Crop X brings in more revenue than Y, as can be seen from the profit function. Here the profit function is the maximization or minimization function. So you can see 143x plus 60y, that means 143 is the revenue of crop X and 60 is the revenue of crop Y. Now the farmer has to identify the optimum value for X and Y so that he will get the maximum revenue. Now some more constraints are given, that is X plus Y, that is the crop X and crop Y must occupy the area only less than 75, that is the total area he has actually, and then total storage limit constraint is given, and then farmer cannot spend more than 15,000 to grow the crop. This is his budget. So with all these constraints, he has to find the optimum value for X and Y. That is, here to make the highest revenue, he has to choose X and Y as the maximum value. So this is a generic canonical form actually. Now let us see how this feasible region can be plotted in the Matlab. You can see the code here. So X is equal to 0 to 80, and then Y1 is equal to max, Y2 max, Y3 max. These are the three equations that have been formed from the decision variables, that is the equations that contain the equations of constraints which contains decision variables. Now y top is given, that is after the maximum of all these constraints are formed, we have to obtain whether the selected point is in a feasible region, that is that point satisfies all these three constraints. That is what this y top means. Now area has to be plotted, and then now let us see how we can run the program and what can be the output. So I am going to run the program now. This contour plot is the one which displays isolines on matrix. Yes. Yes, we obtain the feasible region as it is in color blue, and then these are the lines where the optimum point can be obtained. Now I have coded as like it is overlapped with the feasible region, so that the maximum point can be obtained either this or this, or it is actually in the boundaries. So this can be extended to obtain the optimum point x and y. But what happens is, we can code a generic linear optimization problem code. That is, Matlab uses the following format for linear programming, and you can see this lin program function will get the input from the user according to the constraints and the decision variables and its values and its trivial constraints, etc., can be given as an input to this function, so that the optimum value can be found out by the Matlab program function. Now these are the specifications. This exit flag, which tells whether your program or code is actually identifies the optimum value. If not, the error value will be one of these, so that you will be debugging it. Okay. We consider the same problem, and then this can be coded in a using this optimum value can be obtained from this function. So see, we have coded in a as like this. So once we run, we obtain the maximum values. That is, the optimum value of crop x is 21 and then 53. So maximum value he gets is this much revenue. This is for crop x, this is for crop y. So out of his area 75, you remember that the total area he has only 75. That is the first constraints that we mentioned while defining the total number of constraints. So around, if we allot 21 out of 75 acres, if we allot 21 acres to crop x and 53.12 acres to crop y, the farmer will get the maximum revenue. Now the generic code here is coded. Now you can see the explanations in green color. Okay, let us consider RK model. The constraints are given. You may be knowing this from the book Taha. Let me show you the program and I will run it. You can see the length of the objective minimization function and its corresponding coefficients is obtained, and all the inputs are obtained from the user, lower bound, upper bound, and inequality constraints and equality constraints here, and then evaluating. If there are no equality constraints, it will take us empty matrix. That has been coded here. And also the total equality constraint from the user must be greater than 0, then only this entire code will be executed. So you can see this function here, linprog. Now I have coded the exit flag values and then corresponding information to the user. Now let us run this program. Yes, it asks for the coefficients of objective minimization function. Now we should remember one thing: even though the problem is for maximization, we have coded it is for minimization. So what we have to do is, we have to only negate the values of the coefficients of the objective functions. Now for this RK model, the coefficients are 5 and 4 for maximization function, but I am giving us minus 4 minus 5 minus 4, and then is there any lower and upper bound? Yes. So I am providing it as yes. So it asks for the inequality constraints. Equality constraints is 0 here, and then the lower bound for x1 is 0, infinity 0 2. Now it asks for the input. Yes. You can just go back to this video and check the coefficients once again. Yes, you can see the results are the decision variable x1 x2's optimum value is obtained 2.66 1.66, and the optimum value is 20. Exit flag is 1, which means there is no error. The function converged to a solution. Yes, similarly binary integer linear programming is also available. The thing is here, binary means it takes the values only 0 and 1. So any decision variable that we are coding it is eligible for only taking only 0 or 1. The same thing I have coded here. Now similarly we are taking the traveling salesman problem in binary linear integer programming. Now once again go and show you here. See, this is the starting of the binary integer linear programming. It is similar to the integer linear programming what we have coded earlier. Now you can see the difference here. The function is binary integer programming. The optimum value is displayed as here. Now I have considered traveling salesman problem. Just for the simplest case, we have considered all the edges would be of same distance. That means a salesman from any city can travel to any other city with the same distance. Now we have this is the screenshot of the of the program we have run and the results obtained here. It shows the distant variable values where 1 means it is on, 0 means it is off. That means if it is 0, that edge will not come for the optimum value. That is, it is not the optimum path here where the traveling salesman can travel. Okay. Now I have just colored it, the path which were highlighted by this result of the program. Now these are the references. We always welcome your feedback and write your queries to navinview@gmail.com, aravindgautam81@gmail.com. Thank you.